Okay, so um, our chapter, this chapter is all about chemical reactions. Okay, so chemical reactions are the heart of chemistry. So some reactions, such as those accompanying a forest fire or the explosion of dynamite, are quite eventful. Other are much less obvious, although all chemicals reaction must involve detectable change. Chemical reaction involves a change from reactant substances to produce product substances. And the product substances will have physical and chemical properties different from those of the reactants. So as you can see in this figure, this shows an experimenter or the one working in the lab adding a colorless solution of potassium iodide or Ki to a colorless solution of lead nitrate. So what can you see is there is a formation of a cloud of bright yellow crystal where the two solutions have come into contact. So it is a clear evidence of chemical reaction. The bright yellow crystals are lead iodide, one of the reaction products. So we call a solid that forms during a chemical reaction in a solution a precipitate. The reaction is called a precipitation reaction. So in this chapter, we will be discussing the major types of chemical reactions, including precipitation reactions, and some of the most important reaction we will describe involve ions in aqueous solution. So um, we will first look at these ions and see how we represent by chemical equations the reactions involving ions in aqueous solution. So some of the questions that we will answer here are what are the evidence of ions in solution, or how do we write chemical equations for reactions involving ions, and how can we classify and describe many reactions we observe so that we can begin to understand them, and also what are the quantitative description of ions and reactions in the solution. Okay, so you probably have heard nga we cannot operate electrical equipment while standing in water, and also siguro nakadungog na mo about sa kanagaling mga murder mystery nga in which the victim is electrocuted with an electrical appliances nga kanagaling accidental nga nahulog sa tubig tapos nakurintihan siya while naligo ing ana sa mga murder mystery. So actually if ang water is pure lang siya, dili na siya makakurinti because ang tinuod nga water or ang pure water is a non-conductor of electricity. But kanang mga water bath or kanang mga water nga gikan sa faucet, it is a solution nga naanay gamay or naanay small amounts of dissolved substances in it. And this dissolved substances mo na siya ang hinungdan nga ang water nimo would become an electrical conductor. So, mo na siya ang mag-allow sa electric current to flow from an electrical appliance to the human body. So, for us to understand more about this, we will tackle more on ions in aqueous solution para masabtan nato ang mga different properties of a solution. So, okay, so we have here a unique theory of solutions and solubility rules. So, way back, mga around early 19th century, chemists began studying the electrical behavior of substances, and they knew that you could make pure water electrically conducting by dissolving certain substances in it. So, in 1888, the young Swedish chemist named Svante Arrhenius proposed the ionic theory of solutions to account for this conductivity. So, he said that certain substances produce freely moving ions when they dissolve in water, and these ions conduct an electric current in an aqueous solution. So, Okay, so take it for example, you have here, you dissolve sodium chloride in water or NaCl. So, sa itong mga previous discussion, as you can remember, sodium chloride is an ionic solid consisting of sodium ions and chloride ions. So, when you dissolve sodium chloride in water, the sodium ions and the chloride ions goes into the solution as freely moving ions. Now, suppose you dip electric wires that are connected to the poles of the battery into the solution of the sodium chloride. So the wire that connects to the positive pole of the battery attracts the negatively charged chloride ions in the solution because of their opposite charges. Now, similarly, the wire connected to the negative pole of the battery attracts the positively charged sodium ions in the solution. So, as you can see here in the figure. So, the ions that the ions in the solution begin to move, and these moving charges from the electric current in the solution. So consider pure water. So water consists of molecules, each of which is electrically neutral. So since each molecule carries no net electric charge, it carries no overall electric charge when it moves. So thus, pure water is a non-conductor of electricity. So although water is itself non-conducting, it has the ability to dissolve various substances. So some of which go into solution as freely moving ions. So an aqueous solution of an ions is electrically conducting. So okay, so we can divide the substances that dissolve in water into two broad classes. We have the electrolyte and the non-electrolyte. So what are these? What are electrolytes and the non-electrolyte? Okay, so an electrolyte is a substance that dissolves in water to give an electrically conducting solution. An example of this is sodium chloride, or we also call that as table salt. So when most ionic substances dissolves in water, ions that were in the fixed sites in the crystalline solid goes into the surrounding aqueous solution where they are free to move, and that the resulting solution is conducting because the moving ions form an electric current. So in general, ang mga ionic solids are those um, solids that dissolve in water, or ionic solids that dissolve in water are called electrolytes. So, however, not all electrolytes are ionic substances. Certain molecular substances dissolve in water to form ions. The resulting solution is electrically conducting, and so we say that the molecular substances is an electrolyte. Example of this is hydrogen chloride gas, which is a molecular substance. Hydrogen chloride gas dissolves in water, giving HCl in an aqueous form, which in turn produces hydrogen ions and hydrogen and chloride ions in an aqueous solution. So the hydrogen ions and the chloride ions is called hydrochloric acid. So we will look more closely at molecular electrolytes such as HCl at the end of this discussion. Okay, so what about non-electrolyte? What are non-electrolytes? So a non-electrolyte is a substance that dissolves in water to give a non-conducting or very poorly conducting solutions. A common example is sucrose, or we also call this as table sugar or ordinary table sugar. Another example is methanol. It is a compound used in car window washer solution. So both of these are molecular substances. The solution process occur because molecules of the substance mix with molecules of water. So molecules are electrically neutral and cannot carry an electric current, so the solution is electrically non-conducting. Okay, so let's have here an example of an observation of an electrical conductivity of a solution. So this figure here shows a simple apparatus that allows you to observe the ability of a solution to conduct an electric current. The apparatus has two electrodes. Here they are a flat metal plates dipping into the solution of a beaker. So one electrode connects directly to the battery through a wire, and the other electrode connects by a wire to a light bulb that connects with another wire to the other side of the battery. So for an electric current to flow from the battery, there must be a complete circuit which allows the current to flow from the positive pole of the battery through the circuit to the negative pole of the battery. So to have a complete circuit, the solution in the beaker must conduct electricity as the wires do. If the solution is conducting, the circuit is complete and the bulb lights. So if the solution is non-conducting, the circuit is incomplete and the bulb does not light. So the beaker here shown on the left side of this example. It contains pure water. Because the bulb is not lit, we conclude that the pure water is a non-conductor or a very poor conductor of electricity, which is what we expect from our earlier discussion. So the beaker shown on the other side of the example here or in the figure contains a solution of sodium chloride in the water. So in this case, the bulb burns brightly, showing that the solution is a very good conductor of electricity due to the movement of the ions in the solution. Okay, so how brightly the bulb light tells you whether the solution is a very good conductor or it contains a strong electrolyte or a moderately good conductor it contains a very weak electrolyte. Okay, so the solution of a sodium chloride burns brightly, so we conclude that the sodium chloride is a strong electrolyte. Okay. Okay, so when electrolytes dissolve in water, they produce ions, but only to a varying extent. So, we will be discussing now all about what are the strong electrolytes and the weak electrolytes. Okay, so a strong electrolyte is an electrolyte that exists in solution almost entirely as ions. Most ionic solids that dissolves in water do so by going into solutions almost completely as ions. So that is why they are strong electrolytes. An example of this is a sodium chloride. And we can represent the dissolution of sodium chloride in the water in this following equation. Okay. So what about weak electrolytes? So what are weak electrolytes? Okay, so weak electrolyte is an electrolyte that dissolves in water to give a relative small percentage of ion. These are generally molecular substances. Ammonia is an example of a weak electrolyte. So, pure ammonia gas, pure ammonia is a gas that readily dissolves in water and goes into solution as ammonia molecule. Okay, so kana inyong mga when you say you buy ammonia in the grocery store, you are actually buying an aqueous solution of ammonia. So ammonia molecules react with water to form ammonium ions or NH4 plus and hydroxide ions which is OH minus, and we can represent or we can show it here in this following equation. However, these ions, the ammonium ions and hydroxide ions, react with each other to give back the ammonia molecules and the water molecules, as you can see in this equation, this one here. Okay, so both reaction, the original one and its reverse, occur constantly and simultaneously. We denote this situation by writing a single equation with a double arrow, this one here. So as a result of this forward and reverse reaction, just a small percentage of ammonia molecules, about mga around 3%, have reacted at any given moment to form ions. Therefore, ammonia is a weak electrolyte. Okay, so most soluble molecular substances are either non-electrolyte or weak electrolyte. An exemption to this is the hydrogen chloride gas, which dissolves in water to produce hydrogen ions and the chloride ions. And we represent it, its reaction with water by this equation here. We have a single arrow. Since hydrogen chloride dissolves to give almost entirely ions, hydrogen chloride is considered as a strong electrolyte. Also, hydrogen chloride is also called as hydrochloric acid. Okay, okay, solubility rules. Okay, so it is clear from our preceding discussion that substances vary widely in their solubility or the ability to dissolve in water. Some compounds, such as sodium chloride and ethyl alcohol, dissolves readily and are said to be soluble. Others, such as calcium nitrate, which occurs naturally as limestone or marble, and benzene, have quite limited solubilities and are thus said to be insoluble. Soluble ionic compounds form solutions that contain many ions and therefore are also called as strong electrolytes. So to predict the solubility of the ionic compound, chemists have developed a solubility rule. So this table here, this one that I have shown, is a list of the 8 solubility rules for ionic compounds. So these rules apply to most of the common ionic compounds that we will discuss in this lesson. So I will show you, or I will give you an example to illustrate how to use these following rules. Okay, so we have here. Okay, so we have here determine whether the following compounds are soluble or insoluble in water. We have letter A, mercury chloride. Letter B, we have potassium iodide. Letter C, we have lead nitrate. Okay, so what we do here is we should refer to the table that I have shown you earlier for the solubility rule of the ionic compound to see which compounds are soluble in water. So the soluble ionic compounds are those that are readily dissolves in water. And again, the insoluble compounds are those that are hardly dissolves in water. Okay, so we have here letter A. So we have mercury chloride. So according to rule number 3 in the table that I have shown you, or in table 4.1, most compounds that contain chloride ions are soluble. However, this one here, the mercury chloride, is listed as one of the exemption to this rule. So it does not dissolve in water. So therefore, we can conclude that mercury chloride is not soluble in water. Okay, so let's go to letter B. So we have here potassium iodide. So according to both Rule 1, Group 1A compounds are soluble, and Rule 3, most iodides are soluble. So potassium iodide is also expected to be soluble. So we conclude that therefore potassium iodide is soluble in water. Okay, so let's go to letter C. We have here lead nitrate. So, according to rule number two, compounds containing nitrate ions are soluble. Since there are no exception to this rule, therefore we can conclude that lead nitrate is also soluble in water. Okay, so I want you to check that um, most incorrect determination of solubility occurs when the exception are overlooked. So always be sure to check the exemption column in the table. Okay. Okay, so let us summarize the main points in this section. Okay, so first we have here compounds that dissolve in water are soluble. So those that dissolve little or not at all are insoluble. So soluble substances are either electrolytes or non-electrolytes. Non-electrolytes form non-conducting aqueous solution because they dissolve completely as molecules. Electrolytes form electrically conducting solutions in water because they dissolve to give ions in solution. Electrolytes can be strong or weak. Almost all of the soluble ionic substances are strong electrolytes, and soluble molecular substances usually are non-electrolytes, or also called as, or we call that as weak electrolytes. So the latter solution consists primarily of molecule but has a percentage of ions. Ammonia is an example of a molecular substance that is a weak electrolyte. And a few molecular substances, such as HCl, dissolve almost entirely as ions in the solution and are therefore strong electrolytes. Also, the solubility rules can be used to predict the solubility of the ionic compounds in water. Okay, so that are the things that you should remember about um, the ionic theory of solution and the solubility rules. Okay.